Before diving into Flutter code, it's useful to understand a few Dart language features you will encounter frequently. One of the most important concepts is how function parameters work in Dart, as they have some unique characteristics. There are three main types of parameters. Positional parameters. These are passed in a specific order, just like in many other languages. Named parameters. These are wrapped in curly braces in the function definition and can be provided in any order when calling the function. Optional positional parameters. These are enclosed in square brackets and can be omitted entirely when calling the function. Dart also supports default parameter values, which are assigned using the equal symbol in the function signature. These defaults must be compile time constants. You only need to provide the arguments you care about. Others are automatically set to their default values. If you want to make a named parameter mandatory, you can use the required keyword. You will notice that many widget classes use named and optional parameters extensively to keep code readable and flexible. Another Dart feature worth noting is its support for trailing commas. Unlike many programming languages where a comma after the last item in a list or argument list would trigger an error, Dart allows and even encourages you to include one. Though optional, using a trailing comma has a practical benefit. It improves how Dart's built-in formatter structures your code. When lists, function calls, or widget trees span multiple lines, the presence of a trailing comma prompts the formatter to neatly align each element on its own line, making the code easier to read and maintain. Dart is an object-oriented language, so each class can define constructors. A constructor can either assign parameters to fields explicitly, option 1, or use Dart's shortened syntax, option 2. In the explicit version, each parameter is manually assigned to its corresponding field using the these keyword, which refers to the current object. With the shortened, you can declare parameters as this.x and this.y, and Dart handles the assignments automatically, reducing boilerplate code. Both approaches produce identical point objects. However, the shorthand is more concise and is the preferred style you will see most often in modern Dart and Flutter code. In Dart, as in many modern languages, there is a strong emphasis on immutability, making things as unchangeable as possible. This doesn't mean that everything needs to be immutable, but the goal is to minimize how often your objects and variables can be modified, reducing the risk of unexpected bugs. To support this, Dart provides two useful keywords, const and final. You use const when you know a value at compile time and it will never change. For example, const a equal 1 means that a will always be 1, and its value is determined when the code is compiled. On the other hand, sometimes you don't know a value until runtime, but once it's assigned, you want it to stay fixed. In this case, final is the right choice. For instance, if a user types in their name, you don't know what they will enter when writing the code. But once you capture it, you don't want it to change. That's when you use final. It allows you to set the value once and then lock it in. Both help make your code more predictable and safer. Dart doesn't force their use, but encourages it for a good reason. Now, let's dive into our project. For now, we will focus on the main Dart file inside the lib folder, as it's the only required file. This means we could technically have the entire app in just this one file, which is what we will do here. However, Flutter also gives us the flexibility to organize the code however we prefer, splitting the app across multiple files if needed. Unlike languages like Java, which enforce strict file and naming conventions, Dart is more flexible. We can name our files and structure the project as we want. For now, let's assume the main.dart file exists but is empty. We are about to create the simplest app possible. Just to clarify upfront, this will be a basic starting point, and the app won't be functional yet. This is the code for our very first simplest app, written inside the main.dart file. At the top of the file, we need to import any packages we plan to use. The one we definitely require right now is material.dart, which provides the implementation of material design components. So if you explore the material design guidelines and see a UI element, there is usually a matching class in this package that brings it to life in Flutter. Every Flutter apps begin execution with a function named main, which is common to many programming languages. The main function doesn't take any parameters and has a void return type. Inside its body, it contains one key statement, a call to the built-in runup function. This function, provided by the imported package, launches the app. It requires a single argument, a widget that serves as the root of the widget tree and builds the first screen of the app. In this example, the root widget is a center widget, which centers its child widget on the screen. Center accepts only one child, along with some optional parameters not covered here. The child widget is a text widget, also from the same package. Its first argument is the string to display, passed as a positional unnamed parameter, since it represents the main content of the widget. Also, notice the coding style. I use trailing commas whenever possible, especially in widget trees. This helps keep the code neatly formatted, particularly when using automatic formatting tools. If you run this complete main.dart code on your device or emulator, you will see something similar to the screen shown on the slide. The issue here is simple but important. While you are used to reading and writing text from left to right, many languages flow right to left. Flutter is built to support both text directions, but if we don't specify one, the app doesn't function as expected. To fix this issue in our example, we just need to add a second named parameter to the text constructor, text direction. This parameter takes one of the two constants from the text direction enum. Text direction L to R for left to right, or text direction R to L for right to left. Since I'm used to reading left to right, I will choose text direction left to right. After making this change, simply rerun or reload the app. and it should display Hello World centered on the screen. This is simple, but in the next lesson, we will tackle something more complex.